Imagine a vast library. It's filled with books on every topic imaginable, but there's a problem. The books are arranged haphazardly. You want to find information about a specific topic, but it's like searching for a needle in a haystack. Ontologies bring order to this chaos. They are like the Dewey Decimal System for knowledge. They provide a structured framework to organize information. This makes it easier for machines and humans to understand and use. Ontologies are the backbone of the semantic web. The semantic web aims to make information on the internet more machine-readable. Think of it as adding a layer of meaning on top of the existing web pages. This allows computers to understand the relationships between different pieces of information. It's not just about keywords anymore, it's about understanding the context and meaning behind those words. Ontologies are used in various fields like artificial intelligence, natural language processing, and data integration. They are crucial for tasks like building knowledge graphs. These knowledge graphs are like maps of information. They show how different entities are connected. This enables machines to reason about the world in a more human-like way. In essence, ontologies are powerful tools. They bridge the gap between human understanding and machine comprehension. They allow us to represent knowledge in a way that is both meaningful and machine-processable. This opens up a world of possibilities for building smarter and more intelligent systems. In the realm of ontologies, classes are the cornerstones of knowledge representation. They act as containers, grouping similar entities based on shared characteristics. Imagine classes as molds, shaping our understanding of the world. For instance, in a travel ontology, tourist destination could be a class. It encompasses all the places people might want to visit. Each class possesses a unique identity and a clear definition. This clarity is essential for avoiding ambiguity. Within a class, we can have subclasses. This allows us to create a hierarchy of information. For example, under tourist destination, we could have historical site, beach resort, and mountain trek as subclasses. This hierarchical structure is crucial. It mirrors the way our brains naturally organize information. Just as a tree branches out from its trunk, classes branch out into more specific categories. This hierarchical organization makes the ontology easily navigable. It also aids in inferring relationships between different concepts. Therefore, classes provide the foundational structure for ontologies. They group related concepts, establish hierarchies, and ultimately make knowledge representation more intuitive and machine-processable. While classes provide the blueprint, instances breathe life into an ontology. They represent the unique entities that belong to a particular class. Think of classes as molds and instances as the objects created from those molds. Each instance inherits the characteristics of its parent class, but also possesses its own distinct attributes. For instance, in our travel ontology, Taj Mahal would be an instance of the class historical site. It inherits the general characteristics of a historical site, such as being of historical significance and attracting tourists. However, it also has its own unique attributes, like its location in India and its Mughal architecture. Instances populate the ontology with real-world data. They provide concrete examples of the abstract concepts represented by classes. This makes the ontology more relatable and meaningful. Each instance can have multiple relationships with other instances or classes in the ontology. For example, the instance Taj Mahal could be linked to the instance India through the property located in. This web of relationships creates a rich and interconnected knowledge base. It allows us to navigate the ontology and uncover non-obvious connections. Section 4. Properties describing classes and instances. Properties in the context of ontologies are like adjectives that provide further details about classes and instances. They describe the characteristics, attributes, and relationships that help us understand these entities better. Think of properties as the glue that holds the ontology together. They connect different parts of the ontology, providing context and meaning. There are two main types of properties: object properties and data type properties. Object properties define relationships between two instances or a class and an instance. For example, the located in property connecting Taj Mahal and India is an object property. Data type properties, on the other hand, assign specific values to classes or instances. For example, the year of construction for Taj Mahal could be a data type property with the value 1632. Properties add a layer of granularity to the ontology. They enable us to capture the nuances of real-world knowledge. By defining properties and their values, we create a more detailed and informative representation of the domain. In essence, properties are the threads that weave together the fabric of the ontology. They provide the details that make classes and instances meaningful, allowing us to create a comprehensive and interconnected knowledge base. Section 5. The travel ontology, a case in point. Let's delve deeper into our travel ontology to see how classes, instances, and properties work together. Imagine a travel website that utilizes this ontology. The website uses classes like tourist destination, accommodation, and transportation to categorize its offerings. Each category is further divided into subclasses, like historical site under tourist destination or hotel under accommodation. Now, each specific offering on the website becomes an instance. For example, the Taj Mahal is an instance of historical site, and the Oberoi Amarvilas is an instance of hotel. These instances are then described using properties. The Taj Mahal might have properties like location Agra, India, architectural style, Mughal, and year of construction, 1632. The Oberoi Amarvilas might have properties like star rating 5, distance from Taj Mahal 500 meters, and amenities swimming pool, spa, restaurant. The website's search function utilizes these properties to provide tailored recommendation. A user searching for 5-star hotels near the Taj Mahal will receive results that match these criteria. The ontology allows the website to understand the user's intent and retrieve the most relevant information. This example demonstrates how ontologies power intelligent systems. By organizing knowledge in a structured manner, they enable machines to understand and respond to complex queries. This results in a more personalized and efficient user experience. Section 6. Real-world applications, ontologies in action. Ontologies are not just theoretical concepts. They are actively used in various AI systems, revolutionizing the way we interact with information. One of the most prominent applications is in personalized travel recommendations. Travel websites and apps utilize ontologies to understand user preferences and suggest tailored itineraries. Imagine planning a trip to Italy. Instead of browsing through endless options, an ontology-powered travel agent asks for your preferences, historical sites, beaches, budget, travel style, and more. Based on your input, it crafts a personalized itinerary, suggesting destinations, accommodations, and activities that align with your interests. Another crucial application is in semantic search. Traditional search engines rely on keyword matching, often returning irrelevant results. Semantic search engines, powered by ontologies, understand the meaning and context of your search query. This allows them to provide more accurate and relevant results, even if your query is ambiguous or uses colloquial language. For instance, if you search for best time to see northern lights, a semantic search engine understands that northern lights refers to aurora borealis and that best time implies a time period with high visibility. It then retrieves information about the ideal months and locations to witness this phenomenon. Section 7. Conclusion. Ontologies, the future of knowledge representation. In conclusion, ontologies are powerful tools that are transforming the way we organize, access, and utilize information. They provide a structured and machine-readable representation of knowledge, enabling machines to process and understand information like never before. From personalized travel recommendations to semantic search and beyond, ontologies are playing a pivotal role in shaping the future of artificial intelligence. They bridge the gap between human understanding and machine comprehension, paving the way for more intelligent and user-friendly systems. As we generate an ever-increasing amount of data, ontologies will become even more crucial in making sense of this information. They are the key to unlocking the full potential of the semantic web, creating a world where information is not just accessible but truly understandable and actionable.